really, this is another really important question. Also using graphical method to find acceleration. So you're given velocity versus time. So a car is moving in a straight line along the x-axis. The velocity of the car, which is vx, is given as a function of time in the graph, and the position x of the car at time zero is zero, right? Um, so the average acceleration, so it's asking you to find the average acceleration AX of the car during the interval 0 to 10 seconds, right? So we talked about how to calculate average acceleration in one of the lessons. So this is noted by AAVG, and as we said, it's like V2 minus V1 over T2 minus T1, right? So it's asking you from time 0 to time 10 seconds. So what you do is you want to you're looking at really this position here. It's the start and the end that matters. So you have your T1 V1 here, and then right here you have your T2 V2, right? So T1 0 V1 is 6 meters per second, T2 is 10 seconds, and V2 is 2 meters per second. So AAVG becomes 6 meters per second minus 2 meters per second over 10 second minus your second. So this is 4 over 10 meter per second square, which is 0.4 meters per second square. This is how you find average acceleration. Also think about if you're asked to find the instantaneous acceleration, what would you do? Remember that velocity is the integration of acceleration, and acceleration is a derivative of velocity. So if you're asked, let's say at this region here, and you're in this region, you just find the slope. So that slope becomes the acceleration. And similarly in this region, this is non-accelerating, so it becomes 0 in this region. And then from 0 to 4 seconds, that's decelerating. Again, you find the slope. So using that method, you can find the instantaneous acceleration. So those are the differences.